everyone, welcome to our very first lecture. Today's lecture for environmental issues has quite a few topics that we're going to focus on. What I would really like by the end of this lecture is for you to be able to discuss greenhouse gases, discuss as well as compare and contrast global warming and climate change, and hopefully at the end you should be able to problem solve some issues based around global warming and climate change. We're going to start off with greenhouse gases. So our Earth is surrounded by a thin layer of gases, and we're going to call them greenhouse gases. These gases are what make up our atmosphere. And so they're anything that, such as carbon dioxide, methane, nitrous oxide, and then there's some other really long name chemicals, but they're generally only created by very specific industrial processes. The thickness of our atmosphere and the concentration of its gases influence the surface temperature on any planet. So what the heck is this thing called the greenhouse gas effect? So basically, let's put it this way. If you were to sit in your car when it's really hot outside, and you would notice that the sun's coming in through the windows and the windshield, it's going to warm up the inside of the car. And what happens is you get really hot sitting in there if the car is turned off and the windows are up and everything on a hot sunny day, because the heat cannot get back out through the windshield. And so the car is going to become hotter and hotter because the heat is trapped in there. So that's similar to our Earth. So the greenhouse effect here, in Earth terms, the sun enters our atmosphere. Some of the heat from the sun is absorbed by our planet, but much of it is reflected back. Most of that heat should pass back through the atmosphere and back into space. However, our greenhouse gases are going to trap the heat and keep them in our atmosphere, causing the Earth to warm up. So what the heck is the difference between this term global warming and climate change? I'm sure you've all heard of them, at least in some capacity before. Global warming is the increase of the Earth's average temperature surface due to these buildup of the greenhouse gases in the atmosphere. Climate change is the long-term changes in climate, including average temperature and precipitation. So it recognizes that although the average surface temperature may increase, the regional or local temperature may decrease or remain constant. So when we look at climate versus global warming, climate is really the average weather conditions over time, and global warming refers to an increase in the Earth's average temperature. So this here is a picture of a map that shows the 5-year average variation of global surface temperatures. Now, granted, there's a little video that I don't know how to show that to you, but it shows you the colorings and how the red indicates warmer and the blue is going to indicate cooler. And maybe I can show you this in class next seminar so you can see the temperature patterns and how they change. Well, at the very end, this is up until 2012. It shows you that the temperatures have increased basically in many places over the course of the last so many years. Well, what's going to cause the Earth's climate to change? Well, there's lots of different reasons. We have changes in our atmosphere, and there are two major possibilities of these causes. So there's natural processes, which I'll talk about in just a minute, and the other one is human activities. So if I go back to our natural processes, some things that are naturally causing our Earth's climate to change, we have things like volcanoes. Volcanoes are going to release gases and particles into the air. Plate tectonic changes, which is the changing of the location of land masses on Earth, which is going to affect our wind patterns and current patterns in the oceans, which is essentially going to create climate pattern changes. Solar changes, so the sun can become hotter or cooler over time as it ages. And then orbit changes. So Earth's orbit does occasionally change, but it happens so slowly, over tens to hundreds of thousands of years. So the second thing that's really going to change or cause our climate to change is activities that we do. So anything that we do that's going to release a greenhouse gas into the atmosphere is going to cause that change. So for us, that's things where, we might be directly or indirectly the cause of this, like as individuals. So this includes burning fossil fuels, burning forests or grassland, industrial activities, agriculture. So even though I am not directly at Duquesne Light Power Plant burning fossil fuels, I purchase it and it is heating my home. So I am indirectly using that fossil fuel. Whereas directly I have a vehicle. I go to the get-go down the street and I buy fuel for my vehicle, and I am directly burning that fossil fuel in my car as I drive from place to place. So this here is once again how global warming works. So, we're burning those fossil fuels. They're getting stuck in our atmosphere and warming up the earth, essentially. So we're putting anything that we're really putting a lot of CO2 in excess of in the atmosphere is getting stuck. It's not going back out to space, which is all of these things. So basically, what proof do we have that this is actually occurring? There's a lot of proof. So if we take a look at our temperature trends over the course of time, as well as our carbon dioxide emission data, you can see that over the course of time here, our global temperature has increased significantly. Also, the amount of CO2 has also increased. And so currently, we're way up here at the little more than 380. It's almost like 300, 82-ish maybe parts per million of CO2 produced. This has increased so much more since the 1950s. And so as we have more modern technology and we are utilizing a lot of that technology, but also in the process of learning about that technology, we've utilized a lot of burning of fossil fuels and things of that nature. Glaciers are melting. So our ice caps on both the North and the South Pole. So here's a glacier that was in Alaska. You can see what has happened over the course of time. It's melting. Sea levels are rising, really because of two factors related to global warming: the added water coming from the melting of the land ice and the expansion of seawater as it warms up. And so this here is a graph that shows how much sea level has changed since 1993, which is crazy that the sea level is actually rising. Climate change in the U.S. So temperatures are specifically rising, especially in the winter. We have extreme rainfall and flooding events. Some are more frequent, some not as much. We have extreme droughts and massive wildfires, which are becoming way more common. And then in rural communities, forests, and farmland, they're all impacted because they're making crops and food, which is more scarce and then becomes more expensive for all. There's a few different documentaries I've seen, and it's really interesting to learn about just the soil itself and how some differences we could make by utilizing soil differently that could impact climate change. Climate change is also impacting animals and plants. And so there's phenology, which refers to the timing of plant and animal cycle stages, such as when flowers bloom and birds migrate or when offspring are born. Many of these events are sensitive to changes in the climate and are indicators of changing climate. The map shows plants and animals that are already responding to climate change and those that are projected to respond to this change. So why is this happening? Well, once again, it's because of this increase of our CO2 concentrations. So atmospheric carbon dioxide has increased from pre-industrial concentration of about 280 parts per million to about 400 parts per million in 2014. Carbon dioxide concentration data from before 1958 is recorded via these ice core measurements, which are taken from different places in Antarctica as well as in Hawaii. CO2 concentrations actually fluctuate up and down throughout the year, and these lines are smooth on this graph because it's really showing the average instead of just like the entire year. It is evident that the rapid increase of CO2 concentrations has been occurring since the onset of industrialization, and the increase has closely followed the increase in CO2 emissions from fossil fuels. So you and I are all very responsible for pollution in terms of from gas, from natural gas, from oil, from coal, because we are like not living off the grid and like living by ourselves and trying to be self-sufficient. We rely on heat to stay warm and things of that nature. So what I would like to, so this is kind of just a very basic introduction. I do have a short video for you to watch. It is Bill Nye. That is coming up next. It's short. It's 4 minutes. But I do have a couple reminders. So make sure you are always referring back to your weekly plans so you know what assignments are due and when they are due. Please make sure you attend Open Lab every week at the same time with your same group. That is a requirement. You are graded on that. The syllabus is due next Friday, and that is a way for you to earn either 5 or 10 bonus points. So make sure you take a look at that. And then honors. If you were in honors last trimester, you are already in honors this trimester. If this is your first trimester of science, please sign up, and the first assignment has been made available. All right, now on to Bill.
We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue. But isn't the climate always changing? What exactly is climate change? Why should we care? Well, the Earth's climate has changed throughout history. Most of these slight changes are caused by small variations in the Earth's orbit. But climate change as we know it today is characterized by an abrupt increase in the Earth's temperature. It is estimated to have gotten 1.2 to 1.4 degrees Fahrenheit warmer in just the last century. 10 out of the last 13 years were the warmest on record. 97% of climate scientists agree that this new tendency is not caused by the variations of the Earth's orbit, but rather very likely caused by human activities. That means you and me. And since the Industrial Revolution, we have come a long way. Humans built airplanes, faster cars, developed remarkable technology, and learned how the natural resources around us can be used for our benefit. Although this has led to many wonderful inventions and advancements, like the device you're using to watch this video, or the ability to take a plane halfway around the world, it also means we've increased our consumption of natural resources and, in turn, released a lot of greenhouse gases into the atmosphere. Now, greenhouse gases occur naturally, but in excess can be dangerous to our planet. Modern human activities have increased the release of non-naturally occurring greenhouse gases because we have stepped up our demand for burning fossil fuels. The composition of greenhouse gases traps heat radiated from the sun. The more heat they trap, the warmer our planet gets. And as our planet gets warmer, we begin to feel the effects. One of climate change's biggest victims is our oceans. Oceans regulate the Earth's temperature and provide 50% of the Earth's oxygen. But climate change has increased the global temperature of the oceans by more than 0.3 degrees Fahrenheit since 1969. Although a warmer ocean might seem inviting to a beachgoer, it actually has devastating consequences for supporting life at sea. One of those consequences is ocean acidification, a direct effect of increased dissolved CO2. Since the late 18th century, ocean surface acidification has increased by 30%. A higher acid content means calcifying species, like oysters and clams and shallow water corals, are at risk, putting the entire ocean food web at risk. This is bad news for the 1 billion people relying on the ocean as its primary source of protein. Climate change has also caused the sea level to rise. Just in the last century, sea levels have risen 6.7 inches, but the rate in the last decade is nearly doubled. Sea levels have risen because as the ocean gets warmer, it swells. On top of that, glaciers and ice sheets are melting. Antarctica lost 36 cubic miles of ice between 2002 and 2005, and since 1994, each year on average, the Earth has lost 400 billion tons from its glaciers. That's like an ice cube 7.5 kilometers on a side, 4 miles on a side, melting and flowing into the sea. When all that ice melts, It fills up our oceans, and just like filling up a bathtub, the shores can't hold all that water, and coastal regions get flooded. Troubling signs of climate change are increased extreme weather events. Natural disasters like floods, tornadoes, and deadly heat waves are more obvious to humans because of their immediate impact and their sharing of the images in the media. Climate change, as we know it today, is change in our Earth's overall temperature with massive and permanent ramifications. Although its consequences can be planet-threatening, scientists still believe there are things we can do on a personal level to help. Recycle and reuse things. Walk or use public transportation to get to work. Turn off your electronics when you're not using them. Eat less meat. While you're at it, eat more locally grown vegetables and foods. And last but not least, spread your knowledge and concerns about climate change with others. When it comes to climate change, the main takeaway is that it's real. And although we are part of the cause, we can also be part of the solution.